Hello, Algebra 2 students, for Miss Bell. I'm looking at the Chapter 1 midterm review, Algebra 2, whatever all that is up there. I'm going to go through all of these, and I may have to split it up into two videos. We'll see how long this takes. It's a long time to upload a long video, so let's get at it. And pause this as needed to write down your answers. And to go through this thoroughly to understand it, you may have to stop it, rewind it, and go back and look at it again. What is an algebraic expression for the word phrase 6 times the sum of A and M? So 6 times the sum of A and M, we're adding A and M, and we're multiplying it by 6, so it's got to look like that. Number 2, the quotient of 2 and the difference of x and y. So the quotient means you're going to divide. So 2 divided by this stuff, and this stuff is the difference between x and y. So we have the difference between x and y. What word phrase can you use to represent the algebraic expression? So this is a number multiplied by 2 and you add 4. And you could write it just like that, but I wrote it like this. There's more than one way to do this. So 4 more than 2 times a number. That's the way I wrote it. Evaluating this problem when you are given these values for these variables. So all you do is plug these values in for those variables and you work the problem out. So here's my first step. I just plugged the numbers in. I then did the division and I did the exponent also in this step. As long as you show a few steps, you're good, and you're going in the order of operations. Me doing this division alongside this did not hurt anything, so it just saved me some writing. And then I did that multiplication, it becomes 225, and then I did the addition. Number 5, to which subsets of real numbers does the number 48 belong to? So we're going to start with the most restrictive, which is going to be natural, and then it goes up to whole, integers, and rational. And then from rational we have real numbers. And then we have also this one, irrational. So these are all 5. So what's nice about 5 and 6, you have all 5 listed here. Okay, remember natural numbers are just your counting numbers. Whole numbers are your counting numbers plus 0. Integers are all those counting numbers and 0, and all negative numbers. So you can count backwards, -1, -2, -3. And then rational numbers, you could have a decimal in there, you could have fractions in there, anything that is as a fraction. When you get to irrational are those decimals that don't have an end to them, those when you do the square root of 48, you would see what that ends up being. Here's the example of that. So square root of 48. Let me see here. It gives you another square root. So if it gives you another square root, it says, if I had my red calculator, it would show you the really long what the decimal looks like. It keeps going on and on after the decimal, the numbers. What is the simplified form of each expression? I'm going to rewrite this with a -4 out front, just so it looks a little bit more normal. And you're going to take that -4 times a -6 and get 24. You're going to take that -4 times a -3 and you get a positive 12c. What is the solution of the equation? So this should be a fraction. And so what I did was I subtracted 2 from both sides. And then I divided both sides by a 4/7, and I did that on my calculator, and that gets rid of it over here. 6 divided by 4/7 is 21/2. Yours may come up as a decimal when you do that, and that's fine. You could do either one. Number 9, what is the solution of the equation? I'm going to multiply both sides by 3. That gets rid of it over here, and this becomes 9. Then I'm going to add 3 to both sides. and b equals 12. And if you did that, 12 minus 3 is 9. 9 divided by 3 is 3. Yep, it works. What is the solution of the equation? You can see here I used the distributive property, combined my like terms, isolated the variable. I got y equals negative 10/3. Kind of an ugly answer, but that's what I got. I'm sticking with it. Number 11. What is the solution of the equation? What I did here is I did both steps all at once. I added a 4x to both sides. So I added 4x to both sides. That's how I got the x over here. And I subtracted a 5 at the same time. Got rid of it over here. So I subtracted the 5, so I got 8 minus 5 is 3, so x equals 3. That's how that came about. Number 12, what is the solution of each equation? When I worked this out, when I did the distributive property and then combined like terms, you see that I got the same thing on each side. That's infinite solution. When I got to number 13, I tried to isolate the z by getting rid of it over here. So add 4z, right? So that means I have to add 4z over here. Well, that made them disappear, both of them. And I end up getting 6 equals 1. Well, that's no solution. Should be just no solution, not solutions. 14, what is the solution of the inequality? What I did was I did the distributive property, then I combined my like terms, isolate the variable on one side. I ended up getting a negative y, so I had to get rid of the negatives on both sides. I had to change the signs on both sides. When you do that, when you change the sign or you multiply or divide by a -1, if I multiply by -1 this side, you're going to flip the sign, remember, so flip that sign. And when you go back in there, if I took any number less than 32, so say 31, I plug 31 in here and 31 in here, and I work this problem out, that would be greater than 0. It works. Number 15, what are the solutions of the inequality? Once again, I used the distributive property. I isolated the variable on one side, and I get a is greater than or equal to 28. For 16, I have no solution here because when I get rid of my 8x, say I add it over here, I get rid of it. This tells me that -9 is greater than or equal to -3. That is not a solution. No, that's not true. That's backwards, actually. -3 is greater than -9. 17, what are the solutions of the compound inequality? And graph the solutions. So remember when I am trying to get this x by itself, so I'm going to add the 4 here. That gets rid of it. I have to add the 4 here, and I have to add the 4 here. Okay? That's why these numbers changed out here. And then when I divided by 2, I had to divide by 2 in all sections of this inequality. So I got rid of it here. That's why I did it. This became 5 and this became -3. So then graphing that, x is between -3 and 5. This is solid because it could equal it because it has that little line there. This does not have a line underneath it, so it has to be less than. It could go up to it, but it has to be less than it. And then number 18, I have this one or this one, so I went ahead and solved both of those. You can see how I did that, and then you'll see that actually the numbers to solve this can't be between 0 and 1. It could be less than 0 and greater than 1. Okay, number 19. Absolute value. Remember when you do absolute value, you have what's in the absolute value bars equaling whatever it equals, and whatever it equals as a negative also. Because remember, 1 would equal 1 and -1 would equal 1 because absolute value of -1 is 1. So this value would equal -1 also. So when you work it out, get the variable by itself on one side, I get 2/3 and I get 0. For 20 and 21, we have these inequalities. You could see where I worked, both of them out, When you're doing the inequalities, when you have this, whatever that absolute value equal or is greater than, in this instance, greater than or equal to, you have to flip the sign when you change it to the negative. Because remember, whatever negative in here is going to be the same as the positive. But when you change the negative, you have to flip the sign. So this one's going to be x is greater than or equal to 7, or x is less than or equal to 11. And it looks like that on a graph. And then number 21 was x was less than or equal to 5 and greater than or equal to 9, -9. Okay, 22 was a simplified form of each expression. I used the, I did what's in parentheses first. It's just order of operations here. And then I did the exponents, and then I did multiplication and division. So I multiplied this and then divided by 2, and I got 360. Same thing here, order of operations, real easy. Did what's in the parentheses first, did my multiplication and division. 128 should be your answer. For 24, simplify the form of each expression. You're going to combine like terms. That's all you're doing. This is as far as you can go, because I don't know what m equals, I don't know what n equals. So this m has a 2 with it, so this m with a 2 in it, I could put these two together. So 2.5 plus 5.3 gave me that 7.8. Now these n's are all just n's by themselves. Now say this one had like a little 2 by it, an exponent of 2, it would be by itself. And I just bring it down because there was no other n2's, and then I would just do these two. Since these are all the same, I did 7.8 minus 3.2 minus 5.9, and I got 1.3. And then number 25, I used the distributive property on both sides, and then I got the variable on one side, and I divided both sides by 30, I get x equals 1. And I think that's it. Hopefully this is helpful. If you need more help, make sure you're zooming in on me with the math office hours. Good luck.